Alright, ladies and gentlemen, welcome to the channel. We've got one in the hot pocket, running the test as you can see. We got our control jig here, and we have our power supply giving us the voltage, the amperage, and the wattage that we're currently running on this unit. These are normal numbers. We are currently running in high speed. Let's go ahead and switch that over to low speed. There's the stop, the all-important stop. There's a common failure on these units, excuse me. Okay, and there's low speed. Okay, and we can see what we are running is 0.625 of an amp and 16.8 roughly wattage. It's going to take a little bit to stabilize, but that's kind of what you want to see there is pretty stable numbers. We had it up to about 175 degrees, and we are starting to reduce the heat from Mr. Heater here and cool it down slowly. The reason we put all this sheet metal stuff around it is to kind of trap the heat like it would be in the buses. You got the fan blowing heat off the radiator from this side, and right down the other side where the electric motor is, you've got the turbocharger. So you got this thing just trapped in heat. So this is the best way that we can figure out here to test this thing to make sure that the temperature it's going to reach, it can handle. That the coil is in fact good and breaking the bearings and seals properly. Okay, so now what we're going to do is we're going to shut it off, like so, and we're going to go ahead and turn the power off, and we're going to go to ohms on the meter, which is wired up here. Okay, and you can see we've got about 45 ohms or so, 43 ohms. It's going to dance around a little bit because of the temperature. Like I said, we're going to slowly cool it down here, so we will see the resistance start to decrease a little bit as time goes by with the cooling. So we will see a little bit of dancing, but that's pretty stable. It's actually better than a lot. So here goes on. That's going to be our low speed, and let's check our high speed. There we go. We're about 15 ohms, 16 ohms, which is good. Good resistance numbers. Something else that you should know we do for these units is any little cracks in the parting epoxy in the coil, we go ahead and clean that all out and seal them up. So that way you get a long life out of your coil. You don't have a bunch of dirt and debris in there causing it to short out eventually. So you can see here, it's running pretty nice, pretty quiet. Everything seems okay. I'm going to put the gas off. Bear with me for a second here. Put the gas off to the heater first. Heater a couple seconds to cool down. Okay, now we can be a little bit quieter for the video. So this unit in particular is going to Lansdowne coach in Virginia. And what we have here is coil number 7309834, and we got gear case number 003, which is right on top right here. It's going to be 003201, and then we got Prevolt serial number 3861CCSR. Alright, so we have this whole serial number protocol we got to follow for tracking what we build. So you see we got a bunch of magnets holding this thing all together so it doesn't rattle everywhere, right? So we'll just go ahead and set that down, like so. There we go. Alright, so that's gonna rattle a little bit, but we just want to take a good look over the case. This bolt is here just to hold the thermocouple on. That's how we're getting our temperature readout. This thing was checked for backlash, and it has about 5 thousandths of backlash, which is acceptable. Get really annoying really fast, huh? Okay, we're taking a look all around it and underneath it now that it's been running for about almost an hour. We can clearly see the case is still clean. Let's go upside down right here. Take a look at the gasket surfaces. You see we got the new copper washers in there, the push washers. Just all around making sure 110% that you get a good fan clutch. Alright, we want to keep our name good. So with that being said, here's the connector. is the same connector that your bus uses. That's what we're using to connect to it. You can see the pins are all there, and the connector is undamaged. Watch out for rotating parts here. Take a finger off, but it's worth it. I'm gonna show what we can here. Okay, serial number info is right up in there. Okay, so we can see it's a pretty good unit. Light just died. Charge that. And let's also take a look here, just so you can see. We're running just under 900 RPM. It's tough to get the reading exactly right, looking at the phone and this, but now we're running about 870 or so. Let's see. There we go, yeah. About 883. Okay. Alright, so we've got heat. We've got RPM. We'll leave the belt a little slack so we get some vibration. So we're introducing all the things that it would see normally in the bus as it runs into it, and then testing it electronically as well. So you can see, obviously we went, oh well, because we're not connected now, right? But you can see we have a pretty good test jig here. We're pulling 0.7 of an amp for the thermocouple, because the thermocouple is powered off right here. So just in case you were wondering about that, someone on a previous video had a question about it. So let's reconnect this. You see, good normal linear connector, and then we have the one for the old style clutches as well right here. Okay, so connected on there nicely. All the threads have been checked. Okay, everything's got a little torque seal on it to show. This is the aircraft grade torque seal. Everything inside the clutch as well. Let's take a look in there. Let's just cut the motor for a second. And that click and spin down is from the motor. It's the soft start stuff resetting. But you can see, nice, clean, well-built clutch. Okay, there's the magnet plates, pretty strong. Okay, let's see if we can get a look at it in operation. Let's turn off the ohm meter, turn the power back on. Okay, and then here's gonna be your low speed. Nice strong activation, not too much throw. If we find worn plates, we change them out. Okay, and then let's go high speed. The high speed, we ran it a little tight, that's why it doesn't slam and it's not so loud on the release. We actually had somebody complain about that. He thought something was wrong with his clutch, but actually it turned out it was just a little extra clearance right here. So when the spring pulled and released, it would slam back pretty hard. Nothing really wrong with it, but we just set them a little tighter now so that we avoid that. It's not really necessary, but as you can see, everything moves and functions the way it should. So let's go ahead and turn the motor back on and continue with our cool down. Okay, all that rattling is all that sheet metal there, obviously. We're gonna make something better for this here soon, but we've just been so busy with orders that we haven't really had time for all that secondary stuff. All right, so as you can see, it's on, it's spinning, and it's not rotating here, which is the way it's supposed to be. Now let's go to low speed. You can see it starts rotating right away, and then high speed. Okay, sounds good, works good. Everything's good to go. We are slowly cooling down, and we want to thank you for your purchase. We want to thank you for watching, and we hope to do future business with you. Thank you.